part of the reason I bought the house. Ooh. Hello, welcome everyone. Welcome to MiceTech Talk. And you're speaking with we are the technical information scientists from the Jackson Laboratory. My name is Dr. Sarah, and I am speaking to you from Down East, Maine.
Hi, my name is Dr. Dolores, and I'm coming to you from Fair Oaks, California.
So part of our job as a technical information scientist is to serve the research community. And you may have called us, or you may have emailed us, you may have spoken to us, or you may have, back when we were traveling, seen us at an on-site visit once in a while. But we love talking about science and research. And so that's why we started these MiceTech Talks.
Yeah, MiceTech Talk is a weekly 15-minute podcast-style webinar where we answer frequently asked questions regarding mouse modelings.
And so hopefully you got something to drink, coffee, tea, or whatever your preferred beverage is, because it is time for today's MiceTech Talk. And today, let's talk about latest advances in Alzheimer's disease research. So we have a couple different discussion topics, but you can ask questions, and we're going to try and address what we can. Also, feel free to shout out where you're emailing from or where you're listening from. We always enjoy seeing how far people are listening from. So, Dr. Dolores, to start, what was the conference you went to?
Yeah, last week I attended the Alzheimer's Association International Conference, AAIC 2020. That was supposed to be in Amsterdam, so it was a bummer that I couldn't travel there, but we did the best we could. I listened to hours and hours of different talks, and today I'll summarize very interesting talks, mainly on the role of the cardiovascular disorders contributing to cognitive impairment and dementia, as well as very interesting variations of mouse models that people are using.
Cool. And tell me a little bit, because I haven't gotten to go to one of these virtual conferences yet. You know, what was it like? How did it feel to be virtually present at a conference?
I mean, it has pros and cons. In this particular case, one of the pros was that the registration now was completely free. They had record attendance. Over 30,000 people attended online, which was nice. And you have also the benefit of you're listening to a talk. You want to go back to, revise a concept or something. You can always do that because it's on demand. So that's great. The downside is that you don't have the one-on-one interactions. You don't walk by the posters and can talk to somebody, at length about something. That part I missed. But but it was a great conference. It was super good.
Great. Yeah, I'm really interested to see how things are going to play out over the next 6 months with conferences. So it's really great to hear your experience. So let's get into sort of the meat of the matter. Tell me a little bit about. So I've heard about the amyloid cascade hypothesis. Is that still standing as far as history of biomarkers and how biomarkers change with progression from mild to cognitive impairment to dementia? Oh, perfect. Look at these images.
Yeah. So this is a slide that anybody that went to a talk in Alzheimer's have seen a million times, and I'm showing it 1,001 times here just to show the next one. So basically, biomarkers start by seeing amyloid beta 42 in the in CSF. You can see it later in the brain. And what we are seeing here in this graph is the time from a person that is has normal cognition, moving on more and more progressive cognitive decline and dementia eventually. And on the y-axis, we see biomarker abnormalities. So the news to this, at least it was news to me, is the fact that vascular biomarkers are seen much earlier than anything else, which to me was, like I said, it was kind of new. And I focused a lot on talks that talk about what about cardiovascular abnormalities would tip you more onto progressing into this matter. So that was something that to me was kind of sort of new. I learned a lot about that. There was an interesting talk from one of the PIs from NIH talking about the vascular contributions to cognitive impairment. And as you can see, there's a lot of overlap between cardiovascular problems, not only stroke, but also other cardiovascular disorders, and not only Alzheimer's disease, but cognitive decline in general. Think about stroke, microbleeds, things like that.
Okay. So it sounds like there's a lot of studies that are pointing to this vascular insult and its effect and its contribution to cognitive impairment. Do you have any other examples in that regards that we can look at?
Well, there were a lot of talks that focused on hypertension, which is very common in the population, as you know. There was a fantastic talk from Constantino Iadecola that talked about sort of the connection between hypertension and the effects that it has in cerebral blood vessels, and on top of that, promoting also amyloid beta pathology. So the way he explained it is how, he used these words: hypertension is a major disaster for the brain because it promotes atherosclerosis, which leads to occlusion of the arteries in the brain, and it produces all sizes infarcts, microbleeds, and lipohyalinosis, which is the thickening and weakening of vessel walls that affect the subcortical white matter. So basically, why is this important? Because the white matter underlines being able to connect different regions of the brain, underlines cognitive impairment, and sort of disconnecting these different areas slows down your cognitive processes, which is a lot of times what you see, on top of directly promoting AD pathology.
So hypertension has an effect on the clearance of some of these biomarkers like A beta and tau. Is that kind of what I'm understanding?
Absolutely. Yeah. So basically, if your cardiovascular system is not healthy, you're going to have a much harder time clearing those abnormal forms of A beta and tau.
Okay. And what can you tell me more about the kind of interdisciplinary approach to this research?
Right. So what I was listening, and perhaps that's why, because I come more from the neuro end of things, not so much from the cardiovascular fields of research from my background. And apparently, there has been a huge divide in the research programs that both cardiovascular contributions to cognitive impairment, they're doing the research on their own fort, if you will, and then Alzheimer's disease research are doing research from the other. But there wasn't traditionally not too much connection between both fields. So there's a lot of work,
trying to bring them together.
Building interdisciplinary research teams to study the relationship between brain cells and blood vessels. So it's important to not focus only on the blood vessels or not only on neurons and glia, but just look at what it's known as the neurovascular unit. Just look at that, the neurovascular unit in conjunction with the immune system. There were tons of talks about how your immune system can play against you, if you will.
All right. I want to take a little bit of a aside because obviously, here at JAX, we focus a lot on the mouse models. Can you tell me a little bit more about what mouse models were featured at the conference?
Right. There were tons of talks about mouse models, obviously, and I'm going to focus here on the idea that people are using are improving traditional classic models of familial AD by breeding them with different strains. So in this example that I put here is the RTG4510, which is a classic model. It's an inducible model of tau pathology. And what they have done is bred it with a very common strain, APP-PS1 is the nickname of the strain. And what they are doing is they are trying to recapitulate the progression that I showed in the first slide. They are trying to first turn off tau at the beginning, only let the amyloid plaques accumulate like it happens with people. First comes amyloid plaques, and then later on in life turn on tau, and that makes a more sort of recapitulates better what is in humans. So that's one of the things. And then there was work from the Jackson laboratory that I was a little bit familiar, but I listened to the talks again. They have used the same model that I told you before, the APPPS1, which is a classic familial, very strong, very potent model of amyloid plaques. But in this case, what they did is they bred that particular model to different genetic backgrounds, very different. PWK, CAST, WSB, and BLAC6, which is the default. So the long story short is that if you are looking for specific phenotypes, let's say that you really do want to dig in more into the vascular abnormalities in Alzheimer's, then what they showed is that perhaps better than a BLAC6 APPPS1, you should be using perhaps, or should be considering, the WSB version that has that phenotype a lot better, in addition to neurodegeneration. On the other hand, if your thing is looking more at immunology of Alzheimer's and microglial response, or finding treatments to mellow that down, what you can do is, for example, use the same transgene, but in the PWK strain. So that's something that, of course, the talks were a lot longer than that, but that's kind of a long story short, what they have done.
So genetic background matters in this case.
Matters so much. So much. This is another one from the Jackson laboratory that used the 5XFAD, which is another battle horse for mouse model for Alzheimer's. And this is very neat, because what you can see here on the left in this graph is chart where you can see human population with APP familial mutations, or PS1, which are very penetrant mutations for Alzheimer's. But even if they have the same mutation, as you can see here, the age of onset is very variable. So it means there's a lot more things going on than just the mutation in these genes. And what this group tried to do, led by Catherine Karzowski, is to breed these mice with a panel that is genetically diverse. And I'm going to, again, summarize this very quickly in the interest of time. But what they wanted to find is exactly that: find mice that have the same mutation, however, they are resilient to Alzheimer's. And on the other hand, find mice that are very susceptible, a lot more susceptible than the average. And then look at RNA expression, look at other phenotypes. And for example, they found that, and it makes total sense from what we know about Alzheimer's, that the resilient mice, one of the characteristics that they have is that they have lower number of glia, which can be problematic if you have over-inflammation, over-response to plaques, and higher neuronal load, which explains why these mice were doing a lot better in elevated plasmase and other behavioral studies that they were doing. So, just sort of thinking outside of the box a little bit, instead of using mice that the classic ones, sort of more nuanced mouse models that would bring more information about why is Alzheimer's so so diverse, and there's such a range of phenotypes as well. And then there were a lot of talks about the late onset models of Alzheimer's that the Jackson Laboratory is doing. A lot of talks about characterizing the fact that there's a humanized APP, humanized tau, and so on. And the cool thing is that they are not only making all these new models, but also they are looking at these models with different diets, with exercise or not exercise, trying to understand how the environment and the genetics sort of play together to develop Alzheimer's.
All right. It's so much cool stuff, and I could let you talk about this for probably a lot longer. But this is supposed to be one of those short talks, 15 minutes. It's short and sweet. And I want to get to one question that we got in the comments, which was before we get going. So before we let everyone get back to the rest of their lives and finish their coffee, are there any other early biomarkers of Alzheimer's disease? Any other way of kind of diagnosing the model that you heard about in this conference?
Right. That's a great question. I mean, in the old days, well, not too long ago, I should say, the only way to for sure diagnose Alzheimer's was post-mortem, looking at the brain, looking for plaques and tangles. That was the, for sure way to diagnose
the gold
Alzheimer's.
Standard.
The gold standard. Then after that came PET scans with markers, ligands to amyloid and tau, but those are expensive. So the breakthrough that got some press exposure as well is the fact that there's a blood test for, it's a blood biomarker for an abnormal form of tau. It's called p-tau 217. That seems to, line up very well with amyloid plaque accumulation. Like if you compare the levels of that protein and the PET MRI imaging work, it aligns anywhere from 89 to 93% accuracy. So it's great news, and that could be easier not only to diagnose Alzheimer's, but also to follow progression and follow different lines of treatment.
Yeah, it's really great news, and it's really interesting to hear some of the new advances. Obviously, there's too much to cover in 15 minutes. We have links in either the LinkedIn post, which should be, the LinkedIn should be above. If you're watching on YouTube, the link should be below, but we have links to some resources that you might be helpful for you to dive more deep into this. And next week, it's going to be Let's Talk Mouse Health on Arrival, and that's going to be a really good one. So please come back, put in comments, questions, and if you have any topics that you're interested in, feel free to throw those in the comments as well. We're always interested in what you want to hear. So that's me signing off. Stay healthy, stay safe, and stay excited about research.
Thank you so much for listening.